A student at a four-year college claims that the mean enrollment at four-year colleges is higher than at two-year colleges in the United States. Two surveys are conducted. Of the 35 two-year colleges surveyed, the mean enrollment was 5,068 with a standard deviation of 4,777. Of the 35 four-year colleges surveyed, the mean enrollment was 5,466 with a standard deviation of 8,191. So let's begin by setting up our hypothesis. Again, do not go straight to StatCrunch on some of these. If you are doing 4 or 5 of these right in a row, you might be able to do that, but in the beginning, write down your HO and HA. So, in fact, on this one, I'm going to actually do a pre-step, and let's define. I have two samples here. Let's go ahead and define which one is sample 1 and which one is sample 2. So I'm going to let mu sub 1 be the two-year colleges and mu sub 2 be the four-year colleges. You could have flipped that. I normally do whichever one comes first just in the problem. So now that we've stated that, our HO is going to be mu1 equals mu2. Again, HO is always equals. Another way this can be expressed is mu1 minus mu2 is 0. For HA, I'm going to say, and you got to be a little careful here, particularly by the way I've defined mu1 and mu2. So mu1 is the two-year colleges, and mu2 is the four-year colleges. So mu1 is less than mu2, even though it says higher than. Look at what's higher than. We're saying the claim is that four-year colleges are higher than two-year colleges. So that's why my inequality is going the direction it is. So now that I have that stated, let's go ahead and turn to StatCrunch. We're going to go to Stats, T-Stats, because I'm working with means. So that's a decision you're going to have to make. Once you have proportions and means, you're going to need to decide, am I working with proportions or means? These are sample means that I have. And I have two sample means, and I have summary data. So I let mu1 be two-year colleges. So it says I have 35 two-year colleges, and the mean enrollment was 5,068. With a standard deviation of 4,777. And there were 35 of these. mu2 is the four-year colleges. So 5,466 with a standard deviation of 8,191, and again I had a sample size of 35. We ordinarily do not pool the variances. And here's my hypothesis test I'm going to perform. In the same place, you can also do a confidence interval. So mu1 minus mu2 equals 0. And this time I'm going to say mu1 minus mu2 is less than 0. If it helps, you can choose these optional graphs and press compute. So here's the output. We can see it gave me the sample statistics right here. This is really just what I input. I kind of like being able to see that though. Now, we can see that the mean was indeed greater for four-year colleges, mu2. But the question is how likely is that to happen by chance, if indeed they're the same? Well, the p-value is 0.4, so about 40% of the time I would get a result this extreme if they were the same. So I'm not willing to reject that. These could certainly be equal. A lot of this has to do with our really large standard deviation. And if I look at the p-value plot here, I can see clearly that this is a pretty large area here with a p-value of 0.4 and a t-stat of just minus 0.25 or so. So I failed to reject HO. There's not enough evidence to conclude that the mean enrollment at four-year colleges is higher than that of two-year colleges in the US.